the inception of that discipline, really trying to break down that complexity into simple things. And now we have the same thing like John Nader proposes, this simplicity in design. That's a very noble endeavor, but there's also a huge danger in my eyes to simply misinterpret simplicity as dumping down things and making decisions which produce projects or objects which are easy to use, but at the same time they really are just simple and nothing else. If you look at nature, it's actually the way around, and this is where also the big difference is, like the previous thing that's also in a way the Western reductionist theory and philosophy we have been practicing for 2,000 years. If you speak to someone from Istanbul or from the Middle East or Asia, they might have an entirely different world view of nature, but what is often missing in the reductionist view is this part, namely the way back, that if we take a number of really super simple processes and combine them, we end up with emergent factors which produce complexity and produce results you might never ever have predicted. And if we apply this again to our world around us professionally, there are a lot of people who call themselves creative technologists, but if you are a technologist, or if you were a technologist, for instance, 200 years ago, you were seamlessly moving between all those different fields. There are noteworthy examples, like Ernst Haeckel, for instance, was an amazing biologist, but he was also one of the best illustrators of his time, and he produced amazing plates which are still now used as reference for people worldwide. I want to talk some more about Douglas Rushkoff and his theory, or it's actually not a theory, it's plain fact. And the reasoning he gives for that quote and for that view is that if you look back in history and take the appearance of media in society, if we start with the emergence of the alphabet some 4,000 years ago, you always had this elite, which were the small group of people who actually could use that medium proficiently. So if you take, for instance, text or the alphabet, the elite were the high priests back then. Most people at this time only really listened to each other, or they talked to each other, but no one really could write anything. Only those few selected people who were incredibly powerful. Then we had a few thousand years later, we had the printing press coming along. You might have thought, okay, now this is the moment in time where people can publish their thoughts and write stuff, document their lives. Hasn't happened really for the vast majority of society. It's again just a small subset of people who publish books. Most people at that time only started reading. Always just one generation back behind. And now we have the new next medium, which is code. And we have again a relatively small set of people who know how to program. Most other people only now start publishing, namely blogging. So we have this always one generation of media lagging behind for the vast majority. And this is something which really needs to change, in my view, and not just in my view, there are a lot of other people. And the best approach to achieve that goal, to get people more clued up about the technology we live in. We live in a digital society already. It's not just a hype word anymore, it is fact. But how many people can use code? So we need something called open source, which provides tools and knowledge for free to anyone. So the only boundary between people and technology becomes time and interest. With time, this is something we all have to manage ourselves, interest, same. But if you believe in this whole open source philosophy, you get also tools which include all those four basic freedoms, and you don't get them with the commercial product. And open source really creates this permanent value in society. And a lot of people think either that open source is commercial suicide, or just sheer arrogance, people trying to show off their feats, what they can do, and try to get social reputation. There's a little bit of truth in both of them at the moment, but I think that will change as more and more people start becoming active in this culture. So only fools need tools. If we stop thinking about all the Photoshops and Illustrators and Mayas and Cubases and Logics and whatever we are using all the time, and just stop, put them away, and take those new sets of tools, which are actually not new at all. They are very general tools, and they are simply mental tools. But all of them we do need, and there's actually time axes involved as well. They're not just sorted by word length. But before we can write a single line of code, we actually have to do all those things in our head. Decomposition means breaking bigger, complex things down into smaller, easier to solve, easier to grasp concepts. Abstraction means to generalize them and try to extract really the core of them, which can be reused in different ways. Interaction here not just means man-machine interaction, but also the interaction between systems. For instance, what happens when you put your cash card in an ATM? What happens after that moment? What happens to, how does the bank actually communicate with the ATM? These are all design problems, and most of us are really excluded at the moment because we don't actually know and we don't actually care. But now with the recent, for instance, WikiLeaks debate, you might have noticed how dangerous that might be to democracy if we let other people hide all those decisions and we simply stop caring. And these are just early precursors of what might come. So all those steps we really are doing in the back of our heads anyway. Most people do them unconsciously. The only thing what sets a programmer mind apart from a normal mind is that those steps have to become a conscious act of thinking. And all those modeling tasks have really to do with creating design spaces. And with design spaces I mean that we stop thinking about producing individual designs, singular outcomes, but really think about design as a system we create which can produce a multitude of outcomes, just like nature does, for instance. So if you look at this tree, for instance, this is completely grown out of 3 simple rules which are reapplied over time, over and over again. So we have it's also an open source tool called context-free design grammar, where you can really experiment with the simple design rules, and there's a really helpful community as well. So it's for OS X and for Windows, Linux. So it's really good introduction. So we have, for instance, one rule up there on the top which simply deals with growth. The second rule which deals with orientation of growth, and the third rule deals with branching. So these are the 3 rules we need, but how did I get to this point? Well, if you think about what happens the moment you put a seed in the ground and that seed starts growing, it obviously starts growing immediately towards the light, just like a plant always does. And so it shoots up positive this way. But as we know, the sun is constantly moving around in the sky, so that growth will never be a straight line, it will always be slightly wobbly. So this is what the second rule takes care of. It randomizes the growth direction in the simulation. And once that shoot has a certain height, it needs to balance itself more. And how does nature solve that problem? By creating branches which balance the average growth and keep it in this vertical direction. This is exactly what happens. And as you can see here in those circled values, these are actually in a way weights, probabilities for those rules to fire. And if you, this is basically the same concept as DNA has. And if we change the DNA, we can get from the same process a large number of trees, which Some of them might have nothing to do with each other. If you would show someone that image in the top left and the one in the top bottom and bottom left, sorry, top right, bottom left, you would not expect to have those two designs created from the same process. And if you manipulate the third parameter, I'm just stepping here back and forth, you can see that some of the designs are more stable than others. So for instance, the one here on the bottom left shows the least changes compared to, for instance, the one in the top right. Yeah, so that is, for instance, maybe a possible explanation why trees look like this in nature, because simply nature has forced a certain genome to be more stable. So, similar thinking, multitude of outcomes from a simple process that was a design task I need to solve early, pretty much exactly a year ago, where I was working on a kinetic installation. I needed laser cut wheels, which fulfill a few design constraints. They need to be as cheap as possible to produce because I needed 500 of them. And so what is important in fabrication costs is the length of cut paths and also the number of them. And so I wrote this little 100-line program which can create basically billions of different wheels. And here, for instance, all those wheels only have 3 spikes, those have 4, and then it increases up to 12. And basically for every design I can measure how much that will take in terms of cutting, so I can come up at some point with an optimum result. Obviously there are subjective factors as well. Which wheel do I like the most? You know, I mean, those things can't be quantified. But then you basically can write from a 100-line program, you can get a physical object. This is how far we are these days. And here's another example where I use a simulation of a biochemical reaction. It's called, this simulation is called a Gray-Schwarz reaction diffusion. So you have, this is a map of the process outcomes. So you have 2 ingredients. One increases towards the right, the other increases towards the bottom. And you can see there's this diagonal where you get the area of interest, where those 2 ingredients actually really interact with each other. So all those different patterns, you can then also, for instance, apply with a typography mask and combine those to literally grow letters. So we can see the process in action here. So basically all the points which are inside a letter shape get a different set of concentrations than the ones outside. And all those movements, this is all emergent behavior. I had no idea that would happen. And all those patterns actually only appear by every single pixel looking at its 4 neighbors only. Nothing else. There's no higher intelligence required. And so you can see you get very quickly into philosophical and religious territory. You're simply working with things like this. If you then take all the frames from that animation we just watched and